Yes, I am. Okay, I'm going to start.
Okay.
Okay. Hello and welcome everybody. Thank you for joining us. My name is Gelebogile Nonzaba and I'm the editor of Food Review magazine. I am just having a quick look at the room and I see our numbers are nicely filling up. I think I'll just take about a minute or so just to let the room fill up a bit more. Yeah, I won't take up too much time. I just want to wait for the room to fill up a bit. Just a few more minutes for the room to fill up and then we'll start. To those who've already joined, hello and welcome. We're just using this time to wait for the room to fill up a bit. We will start shortly. Okay. As mentioned, my name is Gelebogile Nonzaba, and I'm editor of Food Review magazine. I'm joined by Michael White, Director of Business Development for Closures from Husky Technologies. Today's presentation will be focusing on innovations in sustainable beverage closures, lightweighting, tethering, and PET closures. Now, before I hand over to you, Mike, I just want to go through a few house rules just to ensure a smooth session. Please note that a link of the video will be available tomorrow to download from our Food Review website, and it will also be shared via newsletter. Excuse me. Should you experience any technical issues, please press the reconnect button at the top of your screen. And then we are going to have a Q&A session towards the end of the presentation. However, we would like for you to send through your questions during the presentation, and we will address them during the Q&A session towards the end. I am now going to hand over to you, Mike.
Thank you.
Yeah, you can start.
Thank you. And thank you, everyone. Good morning, good evening, good afternoon from wherever you are. And again, thank you for the privilege of your time for joining our discussion today. I've divided our talk today into three distinct areas. The first one is the use of simulations to actually promote lightweighting of closure products and enabling speed to market. I then will switch to talk a bit about tethered closures and opportunities for premiumization, differentiation, and how those are being leveraged even outside of the jurisdiction where the legislation exists in Europe. And then finally, I'll close the talk today talking about our PET closure and how it helps to enable the circular economy. So let's get right into it. So I want to give a bit of insight into our methodology on how we develop closures here at Husky. And we divide it basically into two areas. There's the virtual environment and the physical environment. And we'll start here with the virtual environment. And by virtual, I'm meaning using the simulation tools, the CAD tools, the software tools to actually design, develop, and actually prove out the closure from a mechanical and flow perspective to optimize the design for real world applications. So the first step is in the top left here is the closure type and finish specification. And really what we're doing there is we're sitting with the customer and identifying, what type of application are they looking for? What type of beverage are they looking to affix this closure to? Is it a juice, sport drink, or tea? Is it a carbonated beverage, or is it a still water, or some other variant thereof? Once we have that down, it's defined. It's then okay. Are we using a custom finish or an industry standard finish, like from the SETI organization? So there's a wide range of different considerations there. What type of grip zone are you looking for? Are you looking for a 72 neural pattern, a 30 neural pattern, 120? So there's a whole list of different specifications that must be considered there. Again, we have this methodology is applied to all of our closures, whether they're from our standard portfolio that are available off the shelf for industry standard neck finishes, or if these are for custom designs. So there's a bunch of criteria that we go through before we actually start into the CAD work. And that leads us to number two, the closure and finish concept design. And here we're looking at aspects like the top panel thickness, what is the weight target, what kind of plug seal design should we be leveraging, how much preload is required on the plug seal, the thread design, amount of contact surface, and then looking at tamper evidence. Do we need a molded in bridge solution, or is a slit fold sufficient? Once we're satisfied with that specification and we have our design that meets the step one, we'll then move into the simulations. And here's where we can actually simulate how the resin is flowing through the cavity and filling out the part. Is there preferential flow in certain areas? Is there areas where it's not filling as we expect? And then, as this is an iterative process, meaning we can go back to any of the previous steps and tweak the specifications so that we can get a good flow. Then the next step, once we're satisfied with the flow, we then move into the mechanical FEA. And this is where we're actually simulating forces that the closure will experience during everyday operation. Whether it's sitting on the store shelf, whether it's being transported to the store in 40-degree C temperatures, jostling along on the road on the way to the store, how it's being handled by the consumer when it's being open for the first time, if it's being dropped. We want to make sure that all of those simulations satisfy the expectations of the design intent. Once we're satisfied with all of those four areas, that's when we move into the physical environment. And by that, I mean, we're actually cutting steel on the molds and doing our piloting. Once we have the part samples, we then can submit them to our lab to ensure that they meet the dimensional requirements. And then if that's satisfied, again, we can then move on to the third step here in the physical environment, which is the actual physical testing on using a lot of different apparatus within our lab to simulate the real world. And once we're satisfied with that, we can then move to the closure and bottle line trial, where we actually have the 10,000 samples or X number of samples that we bring to the customer's line and actually run them on the line and see how they perform. Again, all of these 8 steps are an iterative process, But what the beauty of the virtual environment offers is a way to expedite the design so we know what we're getting before we even start to cut steel. So it's a means of expediting our speed to market and getting it right the first time instead of doing other approaches like trial and error and hoping for the best. We have a real scientific approach here on how we develop our closure designs. And an ongoing process of that byproduct is what we call here at Husky eliminating waste. And by that I mean when we look at a closure, and here you see a cross section of a typical closure with a bunch of different features. You have your top panel, your plug seal, threads, tamper band, your cams. We look at each one of these features in isolation and say, can we remove weight out of this feature without compromising the performance or the consumer experience? And that's really where those simulation tools help us. So we look at, we divide the closure into all of its subsections or sub elements, like the sidewall, the top panel, cams, etc., and then look at it from a virtual aspect and say, okay, if we tweak the design here, we can save zero point zero 0.01 grams on the design. How does that behave now when we go into the filling? How does it behave when we go to the mechanical simulations? And this is an iterative process and an ongoing process that we apply to every one of our closure designs in our portfolio. So we have a standard portfolio of solutions, and we continually look at how do we take out weight without compromising performance to ensure that we're industry leading. So again, the flow and mechanical simulations I spoke about enabling us to get to the manufacturing stage with a lot more confidence that will work right the first time, and that translates into speed to market. Now, one of a good example of how this approach has allowed us or enabled us to minimize weight, you're looking at a PCO 1881 closure. On the left-hand side is a non-tethered version. On the right-hand side is a tethered version. You can see the elements of the tethering system here in between the tamper evident band and the shell itself. So when we started on the whole tethered journey 5 years ago, when the legislation was first passed, we looked at, okay, one of the criteria, the absolutes, was that we do not add any weight to the design. We need to come up with a design that's tethered, but does not add weight to the closure itself. Because you think about it, tethering is really a sustainability initiative. The last thing you want to do is add additional weight to something where you're trying to be more sustainable. So we applied that methodology that I spoke about in the previous slides, where we look at all of the different aspects and features of the closure and how can we take out weight by looking at the knurls, the shell, all of these features here that are described. And we ended up with actually a zero point 0.1 gram lighter design in the tethered solution than the non-tethered design. And you can see here where the different weights or features where the weights shifted. So they comprise less and in some situations more. But the end result of this was we introduced a tethering feature with a weight savings. So a lot of people think when you incorporate tether, you're adding additional functionality. So by logic, it must add weight to the design. No, we were actually able to increase functionality of the design and achieve a weight savings. And a lot of that is due, or 100% of that is due or attributed to our simulation tools that we have at our disposal. I spoke in a previous slide about our tethered portfolio and our non-tethered portfolio. This is what I mean when I say our portfolio of closure solutions. So again, we have, as you see here on the screen, a wide variety of applications or in other words, closure solutions for the water, for the CSD, for the juice, sport drink, tea markets, and these are mated to or compatible with those SETI industry standard neck finishes. Like starting in the top left here, the 2522. This is an optimized design for the GME 3039 neck finish. And again, depending upon the geography, the customer need, what level of how they want to portray their brand, sustainability, weight. There's a wide variety here of off the shelf solutions that are proven with a variety of different resin and master batch combinations. So we have everything from the lightweight, ultra lightweight 2522 to the more robust, heavier 3025, which is more common in the Asia market, specifically China. And when I say robust, all of these solutions are robust. It's just, again, you have a much lighter weight solution here where you have a much heavier weight solution here. But it all comes down to customer requirements. And the same holds true then on the CSD segment. So we have everything from the 22 millimeter ASSP, which is specific to Coke, all the way through the One Start 2622 family, the GME 3037, the 40 and the 41, up to the PCO 1881 and 1810. And within each of these segments too, we have a variety of different neural patterns and even slightly different weights depending upon the level of performance that's required. For example, the GME 3040, we have two different weights depending on you want to fill for high carbonation at 5.2 volumes of CO2 or down to lower volumes with, say, a 4.2 volume of CO2. And then finally, in the juice, sport drinks, teas segment, we have the 32 and the 38 millimeter. Again, on the 38 millimeter, both 3-start and 2-start. The real key things here are industry leading weights because we're continually monitoring that and ensuring that we have the lightest solution possible in the industry, mated to industry standard neck finishes, and there is never a license fee when you purchase the tooling from Husky. It is just you use that tool to solve and produce as many closures as you need to solve your production requirements, essentially. So that covers the simulations. I want to spend a bit of time now in tethering and talk about the law and where it's headed. So the legislation was passed by the EU Parliament back, it's 6 years ago now, in March of 2019. And it is a pretty comprehensive piece of legislation that outright bans certain materials or products, sorry, I should say, single-use products like cutlery and straws, coffee stir sticks. It requires on the brands and converters of PET preforms to have a certain level of recycled content in each bottle as if it's being sold into the EU. And this legislation took effect, I should say, back in early July of last year. So July of 2024, any single-use plastic package it needs to have, with a volume of 3 liters or less, needs to have that closure retained on the bottle. So tethering is one element of a more broad piece of legislation that focuses on sustainability. So what does that mean? That means essentially, as of July 3rd, 2024, if you are a brand in the EU selling your product, you need to make sure, and your product is less than 3 liters, and it is a single-use plastic beverage container, you need to make sure that your closure is tethered, and meaning it is affixed to the bottle or package in some manner with a certain level of performance requirement. Again, if you're a converter selling into the EU market, you need to ensure that your closures that are being sold into the EU for or destined for the EU are tethered capable. And there's a bunch of other pieces of legislation that are looking to be proposed similar. So this is really the first domino to fall. Um, in the USA, the state of California, the state of Illinois, the state of Massachusetts recently have all passed or proposed, I shouldn't say, not passed, proposed legislation for tethering. In Canada, we have single use plastic legislation. It is not focused on tethering yet, but I anticipate that it will be at some point. So, again, Europe was kind of leading the way in terms of passing this legislation. And then you see other geographies that are passing different elements, either outright banning certain single use plastic pieces, or even looking at passing or proposing legislation for tethering. So again, if I were to bet, gun to my head, you're going to see tethering being passed in other jurisdictions globally as this matures, as the European tethering legislation matures further. You're going to start to see other geographies adopt this. So when we look at tethering, there's a bunch of different ways to create a tethering solution. This is the one that we've here at Husky have come up with, and essentially it comprises three basic elements. You have these arms here on the closure that act in tension. So as the closure is open for the first time, it snaps over in place. So these arms become stretched to a point where they're at their limit in terms of acting in tension. You have this hook that's part of the shell that actually compresses against the flap itself. So this all acts in concert together as to help secure that closure in and lock the shell in position. And you might ask, okay, why is shell locking so important? Well, from a usability point of view, when the consumer goes to drink from the first time or the 20th time, you want to make sure that the shell itself is not interfering with any kind of facial feature on the consumer's face. Um, you want to make sure that it's very intuitive to use. So the last thing you want to do is, as a brand, is introduce a tethering solution that just ultimately frustrates your consumer and it translates into reduced sales because the consumer decides to go with a competing brand because they prefer a better performance or user experience when interacting with your package. And then finally, from a differentiating point of view, and we've seen brands that are outside of Europe actually embrace this and look at tethering as a means to further differentiate their products in the marketplace and through social media. Again, very similar to a slide I showed previously, we have a whole portfolio also of tethering solutions from your ultra lightweight 2522 to your more a larger format design through 3025, which is more popular in, say, Asia, specifically China. On the CSD, again, a wide variety of different tethering solutions. You'll notice as well that we have two solutions for opening angle. So we have one at 180 degree and then the other at 160 degree. And it comes down to consumer preference on which design the consumer prefers, or the brand in this case, or the converter. And then again, in the juice, sport drinks, teas, we have a wide variety here of 38 millimeters. And again, this is an ongoing process. As new finishes are entering the market, we look at having portfolio solutions mated to those industry standard neck finishes. So one that will be introduced quite soon is a 32 millimeter as well, a two-start. Again, just to summarize, two different shell locking capabilities, 180, 160, meeting all the EU directive performance requirements, meaning The closure needs to be tethered and withstand at least 15 openings and closings and 25 newtons of pull force. There's never a license fee with the Husky solution. And again, as I mentioned earlier, we're continually looking at evaluating where we stand in the market and how to ensure that we maintain a industry leading weight for each of our designs. Here's just two examples of customers that have embraced our tethering solution in Southeast Asia. So one is Nature Springs in the Philippines, Nature spring water out of the Philippines. Again, there is no legislation in the Philippines, but the brand here saw it as a means of sending a sustainability message to the market, a means of differentiating their product on the store shelf and even elevating it to a more premium product. And anytime you can do that, you have a positive message from a sustainability point of view, and you want to communicate, hey, we're different. Look at our design. This is why we're different. That's through the whole storytelling, remaining top of mind in the consuming public, through social media, through print ad, what have you, just even buzz among consumers. Anytime you can talk about something new, it helps you remain top of mind in the consumers public, in the consuming public. Another example here is Rare Beverage in Thailand. Again, they looked at it as a means of differentiating their product on the store shelf as well and sending that whole sustainability message. There is no tethering legislation in Thailand, but this is another example of a brand that was looking, hey, you know what? We can leverage tethering to say, look what we're doing. We're trying to be more sustainable with our package, with our closure solution. And they did a very effective social media campaign in TikTok, Facebook, and all of the different social channels. And this kind of is backed up with other examples here where we're seeing more than 30% of our business last year, where there was interest in the tethering aspect of opportunities where the brand was actually choosing a Husky solution where there was no legislation required. And you can see this here highlighted in some of the countries that have adopted tethering. And then finally, I want to conclude with the final section on our PET closure and some learnings that we've seen to date or attained to date, and how this solution really enables the circular economy. So, what is the circular economy? Really, it's in a basic form. It's a model of making, using, and recycling a given product. When we look at beverage packaging as an example, today you have your PET package, and then you have a closure that is typically manufactured from HDPE, and that's really the dominant material today in the marketplace. But with the circular economy, the goal is that the material that makes up that circular economy, in this case, beverage packaging, you want to keep that material continually to being recycled and going back into a new product, so that the bottle that you had yesterday in water is being recycled today. Tomorrow it ends up in a CSD package, as an example. The challenge that we found with HDPE is that it is typically downcycled out of this circularity loop. So although it's recycled, it is downcycled out of a food contact application and moved into something like lawn furniture or pails, what have you. What you want to achieve, the ultimate goal is all of that material that's used in that beverage packaging is maintained in that beverage packaging loop. so that there's the minimal introduction of new material that's required. That recycled content of PET is maintained in that circular loop, and that's really the holy grail. So if you can picture now manufacturing a closure out of PET as well, that would give you your full circular loop and circular, enabling that circular economy by having a package out of PET, which includes the bottle and the closure. So if we think about the closure's role, really, it's to keep the bad stuff out and the good stuff in, right? Through, whether it's environmental pollution, whether it's oxygen ingress or insect ingress, loss of CO2 in the case of carbonated package, you really want to ensure that that package is sealed. What we've developed here at Husky with our PET closure is what we would argue is the industry's most secure tamper evidence that's available on the market, and I'll show you, get into that a bit more now. So here, before we get into that though, I want to kind of set it up so you understand where we're coming from. So today, when you look at a typical closure that's capped on a capping line, I've taken some X-rays here I show on the bottom, but this is really the phase as the closure is being applied to the neck finish itself. You have this cam here on the tamper evident band. It's the feature here that you can see. So they're strategically located around the tamper evident band, covering 360 degrees. But as that tamper band and closure is applied to the neck finish on the filling line, it needs to then stretch over. So the purpose of that cam is to prevent, when it snaps into place, is to prevent the tamper evident band from coming off of the neck. So as it's designed in a one-way fashion. So as the cam passes over the pilfer proof, as you can see here, it finally then snaps into place. But the HDPE has a certain amount of elasticity, which allows it to deform and bend around the pilfer proof. And the same holds true whether it's a integrated cam or a slit fold type of an approach. That those bridges, which are the little connector pieces between the shell and the tamper evident band, are subject to a bunch of stress as that closure is capped onto the bottle itself on the neck finish. And it works very well. HDPE has enough elasticity in it that enables it to deform around that pilfer proof and then return to its original shape without having a high incidence of premature bridge breaks. So if the bridges break, that package isn't sellable, right? So what you want to do is ensure that none of your bridges break when you're capping. When we tried this with PET for the first time, think of the same type of an approach, the material's more brittle than HDPE. What we found is the bridges were breaking. We were getting premature bridge break. And that really caused us then to rethink the design. How do we look at, creating a tamper evidence and a good bridge while preserving the integrity of the bridges themselves? And that's really this contradiction that we were faced with. When you have the closure being capped onto the bottle, you want to ensure that there's minimal interference as it's being applied to promote minimal bridge stress. But yet, when the consumer goes to open it for the first time, you want to make sure that there's maximum interference on the bridges so that there's maximum stress on the bridges and they actually fracture, and that indicates the tamper evidence. So that's really the challenge we were left with. The PET did not allow us to use the conventional design that everybody knows today. So we're left with this question: how do you achieve a good tamper evidence without a good capping window or without any capping window? And that's really where we came up with our tamper evident forming device. This was a prototype that we presented last year at NPE in Orlando. And how it works is this device is actually positioned on the filling line immediately after capping. So as the closures are applied to the bottle, and let me back up here. I'm going to go back one slide or two slides here. Really what you need is a tamper evident band that doesn't have this feature, right? So you can apply the closure without any stress on the bridges. And essentially what it does is these bottles are capped, and then they're passed through and fed through this device, which then through a proprietary technology actually forms the band around the pilfer proof. So this prototype here was capable of 15,000 bottles per hour. We realized that isn't capable of today's filling line speeds or meeting today's filling line speeds. So we are introducing higher output systems at 45, 60, 80,000 bottles per hour. And so we have designs that are then mated to industry standard filling speeds. And again, we showed this. Here's some screenshots here from or pictures from the show in Orlando last May. We were where we actually had the device and we're making it real. So we were passing the bottles through the device and giving them to consumers that were attendees that were able to actually open the package and experience the design for themselves. So this video here shows you how that works, how the whole forming of the tamper evident band works. So again, this was shot in our filling lab here in Toronto, and we'll just get into it here. So again, no changes to the filling line. Um, and you see here, typical filling line. You have your caps on the waterfall sorter being singulated, fed down onto the pickup plate, where the capping chucks then pick up the closures and then apply them to the actual bottle. So here we're just going to slow down. In slow motion, you can see here the capping chucks picking up the bottle or the closures and then applying them to the bottle. So again, no changes to the filling line, except potentially there may be capping chuck optimization, and that's no different than today's HDPE approach, where we ensure that the capping line or the capping chucks are mated properly to the actual closure. So you can see here, as the bottles are filled, they then are capped and then pass through the forming device here. So you can see here, they're going in to be entered into the forming device where it does its operation. And then on the other side, the closures come out with the tamper band fully formed around the pilfer proof. So it's a phased approach. Um, we are looking at focusing right now on non-pressurized, non-carbonated still water, and we're in the early adopter phase. We then move from there to pressurized water applications, and then eventually into aseptic hot fill, and then finally on the CSD side. And as you move up this table, the requirements, performance requirements increase significantly. The requirements for a still water package are a lot less demanding than something like a 5.2 volume filled CSD package that requires venting, proper sealing, and also balancing that weight. So again, we're learning to walk before we run, and we're starting with, you know, the least challenging beverage type, which again represents about 50% of the market. But again, focusing on that, getting that right, and then looking at tweaking the designs to address the more challenging beverage types as you move up the table. So another aspect of the PET closure that I wanted to focus on here is lightweighting opportunities. So if we focus here on the far left-hand side, this is the typical 2925, the GME 3026. So it's a very common water finish in Middle East, parts of Africa, Southeast Asia, Europe. And again, we used this one as a starting point because we were focusing on still water, but we see there's opportunities for additional lightweighting. So the current neck has a 180-degree, 3 times 3, so 3 thread starts with 180-degree length around the neck, and ending up with a total dispensing system weight of almost 3.6 grams. Now, what we saw with the PET closure, being the material properties are much different than HDPE, much more rigid. So you don't need as much thread engagement. So you can get down to 100 degrees of thread engagement, and essentially only by going with 100 degrees versus 180, because the risk of strip torque is stripping the torque, or sorry, the as when you go to apply excessive force, the strip torque is much higher with a PET closure. So again, another reason why you don't need as much thread engagement. You're getting less deformation with the material. So again, you don't need as much thread engagement. You can actually, what we saw here in this example, this area bounded in the green dash lines represents waste. Remember the talk on eliminating waste? This is an example. So we could take 3 millimeters um, out of that neck height and end up, satisfying the performance requirements at only 100 degrees of thread engagement with a 9.6 millimeter thread height, ending up with an all PET package dispensing system weight at 2.9 grams versus the 3.57. To put that in perspective, if you think about a 26-22 3-start, which is a much smaller opening, so it's more on that. If you remember the portfolio that I was showing you earlier on, it was more on the far left-hand side of the portfolio, more for commodity type applications. With this design here, you can get actually a 0.05 gram weight savings on the dispensing system on a dispensing system that has a much larger opening. So, arguably a better consumer experience at a lower weight, all PET, enabling the circular economy. And again, if you, when these hit market, when you get an opportunity to experience the opening, it is much different than HDPE, right? It's very noticeable when you go to open it for the first time. I think we've all been in these situations where we've purchased a commodity type case pack water. So that's available at like Costco here in North America, or the Tesco brand example in the UK, Mercadona in Spain. But regardless, more commodity type. When you go to open it, you're wondering, did those bridges break? Has this been tampered with? That isn't the case at all with the PET closure. It's very clear. You can hear that. It's very crisp. All of them break virtually at the same time. You actually feel it. So it's very clear when you open it that, yes, I felt those bridges fracture. This has never been opened. And then you have that visual cue where the bridges have been fractured. There's been a very noticeable band drop. So I have an example here of the PET closure. You can see, I don't know how it's focusing, but you see that you have that cup. And what I'll do is hopefully the mic picks it up, but I'll hold it up here. But when you go to open it for the first time, it's very clear when you hear it. It's unmistakable when you hear that those bridges fracture for the first time. We're evaluating a bunch of different materials with IVs between zero 0.7 and zero 0.8. Again, this is an ongoing process as it is in HDPE. If you're a producer in, say, Middle East, you will not be able to source materials that, say, are more common in Asia, and vice versa, right? So we're evaluating materials from Samsung. We're evaluating materials from Alpac, materials from SABIC, as an example. So again, all of those materials will be, it's an ongoing process as we're uh, increasing the number of PET resin grades available for the market. Again, if we look at differentiation opportunities, it has the glass-like appearance. Very helps, or sorry, it's very noticeable uh, from an aesthetic point of view, and can really help to differentiate your product on the store shelf. Being fully transparent, you can do some innovative approaches on the engraving. You can actually have it embossed on the bottom of the top panel, so that the top panel, the external surface here, remains flat. So again, just to summarize then on the PET closure, it really helps to enable the circular economy, all of that monomaterial package. As it's being recycled, it's then turning into another package uh, and breathing new life into the material. Again, arguably the most secure TE system available in the marketplace for reasons that I explained. And then there's also opportunities for lightweighting. When we look at the rigidity of the material requiring less thread engagement, opportunities at a dispensing system level to actually take weight out of the full dispensing system. So just a quick few comments on Husky. Globally, global system supplier, primarily focusing in the beverage packaging and medical spaces, preform manufacturing, closure manufacturing, and also medical manufacturing. We also have a hot runner division, which is suited for those industries, plus everything else under the sun, whether it's automotive, 3C, et cetera, et cetera. More than 4,300 team members, more than 470 direct service technicians available. So chances are, wherever your molding location or operation is, chances are that we're not far away. Systems provider, as I mentioned, for closures, preform, medical, and then full suite of tooling products, both custom standard hot runners, and then full tooling solutions for closure, preform, and medical. And then that's all backed up by our proactive monitoring service, Advantage Plus Elite, where we're continually monitoring your operations 24/7 and alert you to potential problems before they become uh, uh, detrimental. So with that, I want to thank you for your time, and I return it back to the moderator for any questions.
Thank you, Michael. If I can just ask you to switch on your camera, please.
Okay. Just 1 second. Hi. I'm sorry, I'm not hearing you. There, now I do. Oh, now I don't.
And now? You
I
should
do.
be able to hear
I
me
do
now.
now. I do.
Okay. Okay. All right. Sorry about that. Michael, we received a few questions which I shall be reading to you. The first one is what impact can we expect on our overall production line when going tethered?
Okay. Um, that's a real good question. I mentioned a lot about the lightweighting, and
Mhm.
we still maintain the overall shape and form of the closure itself. So there is no impacts at all to the capping line. There is one thing when I showed on our tethering system, there was the three elements: the arms, the hook, and the tab. Uh, the tab, we have various amounts of protrusion, and we have all of those solutions running in the field with no impact. Some of them have been running already 4 years in the field with no impact to capping performance vis-a-vis non-tethered.
Perfect. The second question, can PET closures be produced on conventional injection molding machines? Excuse me, for closures slash caps.
Yeah, that's a really good question. And I should have apologized. I should have had a slide on that. Um, yes, the short answer is yes. There is, so if we think about the manufacturing system for a beverage closure today, it's essentially the machine and the mold, and then any kind of auxiliary equipment like conveyors and vision inspection. When we think of a PET closure, the material properties require us to add, if you will, a few other devices. And one is, okay, I spoke about the forming device. So that's one element that's required. The second is on the mold, on the tooling side, we have a valve gated hot runner, not a hot tip hot runner. So what do I mean by that? Essentially, when you look at, here, I'll use a sample here with the closure. If you ever feel on the top of the closure, you feel maybe a little depression or a little nub. That's a gate mark, what they call. And there's two ways to inject that closure and to regulate the flow of material. One is hot tip, where the material just flows around and then it relies on the cooling of the material each cycle to actually then break away. With a valve gate, you actually have a stem, a steel stem that's actually pneumatically or servo driven that closes off and physically shuts off the flow of material. So on our molds, we need a valve gated hot runner. On the machine side, the only change is the screw, the injection screw. And then from an auxiliary point of view, we need a resin dryer. That's no, that's typical in all preform manufacturing, but the resin dryer is actually used to dry the material because the PET material is hygroscopic, so it likes to absorb moisture. So by drying the material pre-hand, beforehand, or during production, steady state production, you ensure that the material is at its optimal condition. So to recap, sorry, on the machine side, screw change, that's it. On the mold side, valve gated hot runner, not hot tip, resin dryer, and TE former. So four things. Sorry, that was a long-winded question or answer
No
for your question.
problem. Thank you. And then moving on to the next one. How does lightweighting impact the mechanical performance of closures across different beverage applications?
Well, what you need to balance, you almost go right weighting, right? So that you need to ensure that taking out too much material out of those different closure features can negatively impact performance. And meaning, say you lightweight the plug seal too much, then all of your sealing performance is gone. So what does that mean? That you end up with then, say on a carbonated application, all of the carbonated gas or CO2 would escape, and when you go to buy it, the soda is flat, or it leaks out. So there's that's why the importance of our simulation tools, to simulate how it fills, how it behaves. More importantly, in the mechanical, in the real world, um, all of those aspects are critical in achieving the right weight, if you will. So as you go lighter, you look at how you take waste out of, or weight out of the subsystems or the sub features. But the more and more you do that, there comes a limit where any more weight removal of a specific feature can negatively impact performance.
Perfect. The last one, Michael, is, have you experimented with RPET on PET closures?
Yes, we have one grade that we've evaluated so far from RCS in Germany. I think it had an IV of 0.8, and that again, as I explained during the webinar, it's an ongoing process of evaluating different material types, and we'll continue to evaluate different RPET grades and how they perform.
Great. I think that is it from our Q&A session. I'm just trying to see quickly, Michael, if I've missed any other questions. Okay, no, I think we've covered everything.
Okay.
Well, and I think we've reached the end of our session. Thank you so much, everyone, for joining us. I hope everybody is leaving with some key takeaways, and we've learned a few things. Thanks again. Thank you again, Michael, for joining us. Please note that,
And thank you
as
for your
mentioned
time.
earlier, thank you, Michael. Please remember, as mentioned earlier, that a link of the recording will be available by tomorrow. You can visit www.foodreview.co.za, and it should be there. Thank you again, everybody. Bye.
Bye. Have a nice day.
You too. Bye.